this is the second part of the Pre-Governor's School Sample Test for Unit 9. And we're on the last page here. So on number 22, we have a punter kicks a football, and its height is modeled by this function h of t. It's a quadratic, where h is the football's height in meters, as t is the time in seconds since the football was kicked. The height of an approaching blocker's hand is modeled by this second equation right here, which we're calling b of t for the blocker, and it is another quadratic, where b is the blocker's height in feet, and that's not supposed to be there, and t is the time in seconds since the football was kicked. Assuming he lines up properly with the ball, when will the blocker hit the ball and how high will it be? So I have a system of two quadratic equations, so I have my calculator open, and I've typed them into y1 and y2. It's real life situation, so I want to go to my window, and I want to think about good values for x. X is the time in seconds since the ball was kicked. So I'm going to set a minimum of 0. And then for a max, it's a football. They're punting it, I don't know, maybe 5-ish seconds. So we'll see how that looks. I'm not sure how high the ball would go. I could probably set my y-min from like 0 to 40 or 50, or I can just do a zoom fit, and then my calculator will choose good values for me. I'm going to try the zoom fit. So that's the first function. That's the path the football is taking, and there is the blocker. So we're going to ignore this part down here that's below ground because that wouldn't really happen. But right over here, it looks like these two are going to cross each other. So I'm going to find the intersection. I'm going to move close to where they cross. And then I'm going to hit enter for the first curve, enter for the second curve, and enter for my guess. And it says that they do intersect at 0.1 seconds. By the way, you notice that the blocker here, it looks like he started to jump before the punter actually kicked the ball, which would make sense if you're trying. Okay, so where is our intersection point? The t, the time, was the 0.1, so I said the blocker will hit the football 0.106 seconds after it was kicked, and then the y would be the height. So the height of the football will be 1.653 feet. I gave units with my answer and wrote my answer as a sentence. All right, in number 23, it says solve for x in the given triangle. So I have this x over here, and when I'm looking at my triangle, there's my x. X is the small side across from the 30-degree angle in a 30, 60, 90 triangle. So I know my ratios for my 30, 60, 90 triangle, and I know, whoops, sorry, put that back. I know that this side over here is the hypotenuse. So if I have my 30, 60, 90 triangles, my ratio of the sides are 1 to square root of 3 to 2. So if I'm going to put some fractions with these, I can say that the x is across from the 30-degree angle, so that would be on the bottom of the 1. I can say that the square root of 21 minus 8x, the hypotenuse, is across from the 90-degree angle, so that would be under the 2. And then I'm not going to use this square root of 3 ratio in the middle because I don't need that one. So I want to solve this proportion. I would cross multiply, so I'd have the square root of 21 minus 8x is equal to 2 times x when I multiply the x over to the other side. So this is a radical equation, and you can see in purple here I've squared both sides to get rid of the square root sign. When I square both sides, I wind up with a quadratic. So on the left side, I'm going to have 21 minus 8x. On the right side, when I square the 2x, I square both the 2 and the x, so that gives me 4x squared. Now what I have is this quadratic. To solve that, I'd like to equal 0, so I'm going to move the 21 and the 8x to the other side, giving me 4x squared plus 8x minus 21. I would factor this, so I could go through and use the area model or whatever I like to do my factoring. And the factors that I get are 2x minus 3 and 2x plus 7. That means my zeros are x equals 3/2 and x equals negative 7/2. Now I have to remember, because this was a radical equation, that I need to check my solutions. When I plug in, I get that 3/2 would work because x can be a positive 3/2. If I plug in 3/2 over here, I still have a nice side length that's appropriate. It's the square root of a real number. Whereas if I tried to plug in the x equals negative 7/2, that would give me a side that's negative, and that means it's extraneous. I can't have a negative side in my answer. So my final answer in the triangles, side x should be 3/2, or you could say 1.5 units long. All right, number 24 is to simplify this expression. It's a review question on simplifying rationals. So the first thing I would want to do is I would want to factor everything. The x minus 2 is already factored. I'll factor the x squared minus 2x minus 8. And it's a division problem, so when I factor, I'm going to go ahead and flip the second fraction and change it to multiplication. Okay, so there are my factors. As I factor each expression, I flipped it. The x squared minus 4 is down here on the bottom as x minus 2 times x plus 2, and the x squared plus 4x plus 4 has moved up here as x plus 2 times x plus 2. Now I want to reduce. Technically, everything on the top is multiplied together and everything on the bottom is multiplied. So any factor on the top that is the same as a factor on the bottom can reduce. So I'll take my x minus 2's and I'll reduce both of them. I will take an x plus 2. It doesn't matter if it's on the top and bottom of two separate fractions or if it's on the top and bottom of the same fraction. Both of those can reduce out. So now what do I have left? I have nothing on the top, so I got to leave that as a 1 because really the GCF of all of this out here was 1. I could leave that as my top factor. On the bottom I have the x minus 4, so that's all I have left down there, and my final answer is 1 over x minus 4. All right, on number 25, I need to simplify the expression. It is a complex fraction, so I have fractions that are added or subtracted inside of another big fraction. So the first thing I would probably do is to rewrite this thing a little bigger, and then I want to find the least common denominator for the problem. I need a p and I need a q. So my least common denominator is pq. What I want to do is, for balance, there is no left and right on this one. There's only a top and bottom. So I'm going to multiply the top and the bottom of the big fraction by pq over pq. When I do that, my pq's will distribute to each term in the whole problem. So each one of these little fractions will have a pq with it. So again, I've rewritten that and put the PQs with them. The reason that I like to do that is because now I can reduce. The P from the denominator will reduce with this P, and my first fraction, all I have left now is 1Q, or just Q. Let's put an equal sign here. In my second fraction, my Q's will reduce out, and I have left a minus, a 2, and a P. So this is Q minus 2P. On the bottom of the fraction, 3pq. There were no denominators here, so I have nothing to reduce. It's just 3pq. Then I had to subtract. My q's would reduce out, and I have 5p left. 5p. I can leave my answer like this, because as I look at it, nothing is going to reduce from the top and the bottom. The other thing that I could have done is I could have left the top the same as q minus 2p, and then the bottom there is a GCF. The GCF would just be p, so if I factor that out, I would have 3q minus 5. It doesn't really matter to me which way you write this answer, but if it were multiple choice, you should be prepared to choose either one or the other. Only one would be listed though. All right, that's it for your test. Good luck, study hard.